Hello students, good morning. Today our topic is Fourier discrete time Fourier series. On last time we were discussing about properties of DTFS, and last property was Parseval's relation. We use Parseval's relation for calculating energy or power in frequency domain when it is difficult to calculate power and energy in time domain. Then proof of Parseval's relation, x of n is given by summation ak exponential jk omega n, and ak is given by 1 by n summation x of n exponential minus jk omega n. We have to prove that 1 by n summation square of mod of xn is equal to summation square of mod of ak, and this is given by 1 by n summation square of mod of xn x of n is given by conjugate of x of n multiplied by x of n. Here x of n is equal to a plus jb, and conjugate of x of n is given by a minus jb. And if we multiply x of n and conjugate of x of n, then we get a square plus b square. And if you calculate the square of mod of x of n, you get the same expression. So this square of mod of x of n is replaced by this, and if we replace this x of n by this expression, here then this x of n is replaced by summation ak exponential jk omega n, and we take summation ak out of this expression, we get this expression, and x of conjugate of x of n is written like this. Similarly, as conjugate of x of n is written a minus jb, here we change this plus j by minus j, and this is the conjugation of ak. So we get summation of ak multiplied by ak conjugation of ak, and this ak multiplied by conjugate of ak is written as square of mod of ak. So we can calculate the energy or power in frequency domain by using Parseval's theorem. Suppose that question is given x of t is k, this is sampling function k multiplied by sampling function at, and calculate the energy of this signal. If you will try this question in time domain, then it is very difficult to calculate the power of this signal. So we try to calculate the energy of this signal in frequency domain. We know that if x of t is equal to some sampling function, and if we take Fourier transform of x of t, then we get Fourier transform of sampling function is a rectangular signal, and this is the bandwidth. This is the bandwidth which is given by a in sampling function, and pi by a is the height of this rectangular wave. Since this is multiplied by k, we multiply this rectangular by k. So height of this rectangular pulse is k multiplied by pi, and a is from 0 to plus A is bandwidth of this sampling function. Energy is given according to the Parshall's relation. N is periodic time. So N is period of time. It is given. Energy is given by 1 by 2 pi integration from minus infinity to plus infinity square of mod of x of omega d omega. And this is the area of square of mod of x of omega. So if we calculate the area of square of mod of x of omega and multiply that quantity with 1 by 2 pi, we get the energy of this sampling function in time domain. So this is the rectangular wave of this sampling function in frequency domain, and this is the square of x of omega, square of mod of x of omega is given by k square pi square by a, and this is the width of pulse. So if we multiplied height, square of height multiplied by 2a, 2a is the bandwidth of this. So we get the area, and if this area is multiplied by 1 by 2 pi, it means that we get the energy of signal. So we can calculate energy of this signal in frequency domain very easily by using Parshall's relation. Examples on DTFS. Determine the Fourier coefficient of periodic sequence x of n is equal to 0, 1, 2, 3. Means this is the magnitude of x of n at n is equal to 0. When n is equal to 1, magnitude is 1. When n is equal to 2, 0, 1, 2 and 3. And period is 4. Because Fourier coefficients of DTFS is also periodic, and period of this coefficient is given by n is equal to 4. So when n is equal to 4, omega naught is equal to 2 pi n, and n is 4, we get n omega is pi by 2. So we substitute this value in m exponential minus j omega naught, which is equal to exponential minus j pi by 2, and exponential j pi by 2 is equal to minus j, because cos pi by 2 is 0, minus j sin pi by 2 is 1. So this is equal to minus j. Then by definition, value of Ck is given by 1 by n summation n is equal to 0 from n is equal to 0 to n minus 1 x of n exponential minus j k omega naught n. Here, if we substitute the value of minus j omega naught, value of minus j omega naught is j. So this expression is converted into 1 by 4 summation from n is from 0 to 3 x of n minus j raised to the power kn. Here, then first we calculate C naught, means k is 0. When k is 0, this is 1. So we get 1 by 4 summation x of n from 0 to 3. And it means that 1 by 4, close the bracket, x of 0, value of x of 0 is 0. Then x of 1 is 1. X plus x of 2, 2. And x of 3 is 3. So we get 3 by 2. Value of C naught is equal to 3 by 2. Similarly, C1 is calculated is 1 by 4 summation n is from 0 to 3 x of n minus j value of k. Substitute the value of k is 1. So k, here we get minus jn, and in as the same case 1 by 4, 0 multiplied 1 when you substitute n is 0, this quantity is 1. In second case 1 multiplied when value of n is 1, this is minus j. When a value of n is 2 plus j square, it means that minus 1 multiplied by 2. And when n is 3, we get j multiplied by 3. So we get a complex quantity minus half plus j by 2. C2 is 1 by 4 summation n is from 0 to 3 x of n minus j raised to the power 2n, where in this value, in this coefficient, value of k is 2. So 1 by 4 summation from n is from 0 to infinity x of n minus 1 raised to the power n raised to the power 2n. When n is 0, 0 multiplied by 1, in this case this is minus 1 plus 2 1 and plus 3 multiplied by minus 1, and this is given by minus half. Next, C3 is also calculated in the same manner, and we get the value of C3 is minus half minus j by 2. So all the values of C1, C0, C1, C2 and C2 are calculated in this question. Find the discrete time Fourier series for the question x of n cos pi by 4 multiplied by n plus psi, where and plot at. Solution: x of n is given by this expression, and omega is cos omega n. Omega is equal to pi by 4. N is equal to 2 pi by omega. Substitute the value of omega, pi by 4, pi cancel, and we get 8. In this case, value of periodic or fundamental period is 8. And then write this expression in exponential terms: half exponential j pi n by 4 plus psi plus exponential minus j pi n by 4 plus psi. Then this equation can be written like this, and here this minus j pi by 4n is written as j minus 1 pi by 4n. It means that this is the value of a minus 1. This is for minus 1, and in this case this is for plus 1. So we can say that this is the coefficient, Fourier coefficient a minus 1, and this is half exponential j psi is coefficient of Fourier coefficient a1. So a1 is given by half exponential j psi, and a minus 1 is given by half exponential minus j psi. But we know that Fourier coefficient in discrete time Fourier series is periodic in nature, and here AK has a period of n is equal to 4. So if we add this 8 to -1, we get A7, A15, then we add 8 to this 7, 8, 15, and value of these coefficient is equal to half exponential minus j psi. Similarly, A1, when we add this, we get A9, A17, and coefficient of all these, value of all these coefficients are equal to half exponential plus j psi. And if we plot these coefficients, this is the value of k. When value of k is 1, magnitude is half. This is magnitude and this is phase. So magnitude is half for A1, for A7, and for A15. Similarly, magnitude is half for A minus 1, A minus 7, and A9. And similarly, phase is given by of AK is given by this diagram. Psi is here, value of phase is psi, and this is given by magnitude and phase spectrum of AK. Calculate the Fourier series coefficient AK for this signal. Xn is equal to sine omega naught n, and plot AK. Plot AK, it means that plot the amplitude and phase of AK. H of n is given by sine omega naught n, and period is n is equal to 2 pi by omega. One minute please. X of n is equal to sine omega naught n is periodic with period n, where n is 2 pi by omega is an integer. Omega n, sine omega n can be written by this expression, and here and this expression is written like this: minus 1 by 2 pi j exponential j minus 1 omega naught n plus 1 by 2 pi j exponential j plus 1 omega naught. Means this is the coefficient of A1, and this is the coefficient of A minus 1. So A minus 1 is written as 1 minus 1 by 2j, or you can write this is equal to j plus half. You multiply j, this, and j square is minus 1, minus minus is cancelled. So it is equal to j multiplied by half. And similarly, A1 is equal to minus j half, minus j divided by half. In this case, period is not given, so period is not given, so we suppose that value of fundamental period is n. So omega naught is equal to 2 pi by n, and xn is given by sine 2 pi by omega 2 pi by 5 multiplied by n. And Fourier coefficients ak are periodic with period n is equal to 5. So we get a1 is equal to a6 means 1 plus 5 is equal to 6 plus 5 is 11. So a1 is equal to a6 is equal to a11. Similarly, a minus 1 is 5. And when we add 5, we get minus 4, and minus 4 plus 5, we get the value of this coefficient. Here you see that value of a1 is minus j by 2, a1 is minus j by 2, a6 minus j by 2, a11 minus j by 2. Similarly, a minus 4, if we add plus 5 in this, we get a minus 4 is also minus j by 2. If we add in this minus 1 plus 5, and a minus 1, is given by j by 2, a minus 6 is given by j by 2. Similarly, a4, a4 means in this case it is given by, if we add plus 5, this is given by j by 2, and if we add a4 plus 5, we get a9, and value of a9 is also j by 2. And in this case, phase angle is given by tan inverse imaginary part divided by real part. Real part is 0, so phase is same for all the angles. Determine the discrete Fourier series representation for the following signal. X of n is equal to cos square pi by 8n, and second question is x of n cos pi by 3n plus sin pi by 4n. Solution: x of n is given by x square omega n, which is written as half 1 plus cos omega by 2 omega n. So we get this, and we can write this expression like this. And cos omega is written in exponential form is this. So we can write half is equal to half multiplied exponential j 2 pi by 8 multiplied by 0 into pi. E raised to power 0 is 1. So we can write this term. It means that this half is the coefficient of, this half is the value of C naught coefficient. Then this is given by half j exponential j 2 pi 8 into n multiplied by 1. It means that this is the value of coefficient C1. C1, value of C1 is given by 4, and This is written like this: z exponential j 2 pi 8 multiplied by n multiplied by minus n, and it means that this 1 by 4 is the value of coefficient c minus 1, and fundamental period is 8, so we get, if we add 8 here, we get c7, c7 or c minus 1 is equal to 1 by 4. Other values of ck when k is 2, 3, 4, 5, 6 are all are 0. So we can write that x of n is equal to k is equal to 0 to 7. ck multiplied by exponential j 2 pi by 8 and k, or you can expand this expression because value of ck is 0 when k is 2, 3, 4, 5, 6. So x of n is written as c naught plus c1 exponential j 2 pi omega n plus c7 exponential j 2 pi 8 7 pi, and if we substitute the value of c naught, c1 and c7, we get this. Next question is x of n is given by cos pi by 3n plus sin pi by 4n, and we can also write this expression like this: 2 pi by 6 and 2 pi by 8. Then convert these are x of n is summation of this wave and this wave. So fundamental period of x of n is LCM of 6, 6 and 8, which is 24. So value of capital N is in this case is 24. Then we write cos omega n in exponential form and sin omega n in exponential form, and then by rearranging this equation we can write this equation in this form, and then calculate the value of c4, c minus 4, c3 and c minus 3, and since value of k is 24, we get the value of c20, c1 and c24, and we can write the value of signal x of n by knowing the coefficient of C. Class is over. Thank you.